Let's look at this graphic organizer here that we have that's going to go in our composition book or might already be in your composition book. And this graphic organizer is all about, it's actually solving equations. And the first, it goes through some goals. So goal 1, simplify any terms needed, get variables on one side and numbers on the other, get the variable by itself, and then check. And so what we're going to notice is there's some suggestions here in things that you may need to do, but you may not need to do. And then, but in general, we solve two-step equations where we usually use adding or subtracting first, and then division second. And it's possible that we could be doing other things in these steps, but this is the pretty standard stuff that we'll be doing. So let's look at this first equation here in this, and you're going to notice that in this equation, let's look it over. Negative 2x plus 10 equals 15. So it says simplify any terms needed. Well, as I look at these terms, I'm looking to see if I need to simplify them. I'm looking for certain possibilities, like is there a need for the distributive property? Well, there's a need for the distributive property whenever you have a number on the outside of parentheses, like that. And then whenever you see that, then you need to do the distributive property first. So you would have to multiply 4 times x and 4 times 3 first before you can begin doing anything else. So in that case, that would simplify to 4x plus 12. But I can see in my first example, I don't really have anything like that, so I don't have to worry about it. The next suggestion is write terms into addition statements. So that might be if you have something like, let's say you had 7 minus 4x on one side of the equation. Well, you might want to change that to flip 7 plus negative 4x. That might make it easier to solve. But if I look here, I don't really have subtraction. I have a negative 2x, but that's not, that would be change flip, I'd be changing to subtraction. I don't want to do that. It already is addition, I should leave it. So the next thing is, the next possibility is, let's say you have like terms. Like let's say maybe you had something like 2x plus 3 plus 4x. If you have something like that as part of one side of the equal sign. Well, if you had that in your equation, then you'd want to combine your x's together, your like terms, but not your constant because it doesn't have an x on it, and simplify that first before you were trying to solve. But we don't actually have that in this equation either. So we don't have to worry about anything from this first goal. So we don't have those possibilities. So let's move down to goal number 2. And goal number 2 says that the goal is to get variables on one side and numbers on the other. So here I have a variable term plus a constant equals a constant. So when we say one side or the other, we're talking about the side of this equal sign. So I like to divide this line down to show there's the left-hand side and there's the right-hand side. And so what we want to do is we want to have it so that only the variables are over here and the numbers are over here. So to do that, we're going to do the opposite operation with the same number. I want to get rid of this add 10. So the opposite of add 10 is to subtract 10. I'm going to subtract it from both sides. And then I simplify down. So 10 minus 10 is 0, so that goes away. And I have 2x, negative 2x left, sorry. And then 15 minus 10 is 5. So now I have my variables on one side and my numbers on the other. Yay. So goal number 3. Let me rewrite this equation as it is now, is to get the variable by itself. Well, right now it looks like it's by itself, except it's being multiplied by negative 2. So the goal is to really just get the invisible 1, x, and know what that equals. So to do that, I'm going to do the opposite operation with the same number. So the opposite of multiply is to divide. So I divide by negative 2 and divide by negative 2. Now when I do negative 2 divided by negative 2, that should give me 1, positive 1x, and 5 divided by negative 2. Well, when I put that in the calculator, I get negative 2.5. But I want you to know that it's also okay just to have -5/2. Because decimals are okay as long as they're terminating. But if we ever get a decimal that repeats, then we really want to change it back to a fraction because we don't want repeating decimals as our answer. But terminating decimals are okay. I like this solution better. That's the one I'm going to use. So now I have my solution, but I need to check. So we're going to use the RSS method to check, rewrite, substitute, solve. So I'm going to rewrite the equation as it originally was given to me at the beginning. My next step is to substitute in the solution I have for x, and everything goes exactly where it was. Recopied it, except that changed to a -5/2. Now I'm going to solve. I'm going to do the math over here, and when I do that, when I multiply -2 times -5/2, I get 5, and 5 plus 10 is 15. On the right, there's nothing to solve. I'm just going to copy it, and I can see that 15 equals 15, so check. My solution checks. So that's a very simple two-step equation. It even has negatives and decimals, and it's really not that hard to do. So let's look at this other equation we have. 3x plus 2x equals 12 minus x. Well, as I look at my first goal, it says use the distributive property to expand. I don't have any parentheses. I don't have to worry about that. Rewrite terms into an addition statement. Well, the only one I have here is on this side of the equal sign. I could rewrite this as keep, change, flip, and make this a -1x if I wanted. But the one that I'm really concerned about is this last one, combine like terms. And I have on the left-hand side, I actually have 3x's and 2x's. So I can combine 3x's plus 2x's and get 5x's. I cannot combine these x's because they're not on the same side of the equal sign. So I can combine like terms on this side. I could combine like terms on this side, but I can't cross the equal sign. To do that, I have to solve. In order for a number or a variable to come across the equal sign, I need to use the opposite operation. Like think about it as almost like a passport to cross the border. You have to do the opposite to get it across. So 5x equals 12 plus -1x is now the equation that we're solving, now that we simplified. Now the last time we subtracted 10 from both sides. So in this case, we have this constant of 12, and so we might think, well, I should subtract 12 from both sides. Or maybe worse, we think we should add 12 to both sides. But I can't do that because on the left, I don't have a constant term to add or subtract it to. So it really wouldn't do anything but move it. It wouldn't really get me any closer to solving. So the term that I needed to move, or the term I'm going to actually, in order to get variables on one side and numbers on the other, because that's my goal, to have variables on one side and numbers on the other, is I need to actually move or get rid of this -1x. So the opposite of adding -1x would be subtracting -1x. But I don't want to do that. I don't want to subtract a -1. Subtracting a negative is really just change. It's really just adding a positive. And I'd really rather add than subtract. So I have -1x plus 1x. If I put them together, that equals 0. So that's going to get rid of it. So I'm going to add 1x to both sides. So now I'm simplifying down. This is gone. So now I'm just left with 12. And over here, 5x's plus 1x is 6x. And that equals 12. So now I have variables on one side and numbers on the other. Look how simple that is at this point. Now we just have 6 times x equals 12. That's easy. But remember, our last goal is to get the variable by itself. The goal is to have the invisible 1x. So the opposite of multiply is divide. So I'm going to divide by 6. 6 divided by 6 is 1x. 12 divided by 6 is 2. So here is my possible solution. Well, my last step is to check. So RSS. I need to rewrite the equation as it was exactly before I changed it in any way. So before I combine like terms, before I change positive, negative, any of that, I have to start at the very beginning, because who knows where my mistake could have been made. So I'm going to do 3 times 2, because I think x is 2. So that's 2 times 2, because both of these have an x in them, equals 12 minus, oh, there it is again, 2. So now I'm going to solve. But now I have to solve on both sides, because both of them have math to be done. So I did this math first. 3 times 2 plus 2 times 2. 3 times 2 is 6. 2 times 2 is 4. 6 plus 4 is 10. On my right, 12 minus 2 is 10. It checks. So there you go. There you have it. Your solving equations graphic organizer. Hold on to it. Have a great day.